Hi, Assalamualaikum and good day everyone. Today we are going to present our basic statistical project. So we are in 4 group members to complete our project group. So each member is responsible for a different section of the analysis to ensure that the project is well organized, accurate and clearly presented. So this project is conducted as part of the requirements for FFT2073 basic statistical course. So specifically, we analyze data set A, which contains information on diet types of disease resistance among patients. So the purpose is to apply the statistical concept to real data set A. So what we learn from our project is how to form research questions, how to select an appropriate statistical test, how to analyze data, and how to interpret the results. So the objective of the analysis is to determine the relationship between diet type and disease resistance using statistical method. And the objective is to clearly interpret and explain the result of the statistical analysis. So now I will pass for the next section.
For 2.1 research questions, the research question for this analysis is there a significant relationship between diet type and disease resistance among patients in database A? For 2.2 hypotheses, based on the research question, the hypotheses are formulated as follows. The non-hypothesis H naught state that there is no significant relationship between diet type and disease resistance. This means that disease resistance is independent of diet type. The alternative hypothesis H1 states that there is a significant relationship between diet type and disease resistance. For 2.3 statistical test, the statistical test selected for this analysis is the chi-square test of independence. This test is appropriate because both diet type and disease resistance are categorical variables. The data are presented in frequently form, and the purpose of the test is to determine whether there is an association between two categorical variables. Now I will pass to Mary.
Now section 2.4. Before performing the chi-square test of independence, several observations are independent. Each observation represents a different patient and no individual appears more than once in the data set. Third, both variables analyzed are categorical variable. Diet type consistent of three categories A, B, C, while disease resistant is classified as resistant or non-resistant. Finally, the expected frequencies in each cell of the contingency table are the greater than 5. This satisfies the minimum requirement for applying the chi-square test. Next, section 2.5, statistical output. Joint frequency table for diet A, resistant is 48, non-resistant to 24. Patient giving a total of 72. Diet B, resistant 44, non-resistant 28. The total is 72. Diet C, resistant 40, non-resistant 60, resulting in 56 observations. Overall, there are 132 resistant and 68 non-resistant patients, make up 200 observations in total. The calculated chi-square statistic S square is 1.5184 with 2 degrees of freedom. The corresponding p-value is 0.468. To make a decision, the p-value is compared with the significant level of 0.05. Since 0.468 is greater than 0.05, the null hypothesis is not rejected. Now I pass to next member.
Okay. Lastly is chapter 3, conclusion and interpretation. The decision rule is if p-value less or than 0.05, we reject the hash now. But if p-value is greater than 0.05, we fail to reject hash now. So from this analysis, the decision that we get is since 0.48 is greater than 0.05, we fail to reject the null hypothesis. So the conclusion is there is no significant relationship between target type and disease resistance. For the interpretation, this means that the disease resistance is independent of target type. Any difference observed in the data sets take due to random variation, not because one target is better or worse than another. So that concludes our presentation. Thank you for watching, and we hope this helped demonstrate how the chi-square test of independence can be applied